I was just thinking it's a lot like adding brains to an intersection, right? Like it makes it so much more intelligent and adaptable to what's actually happening, because as good as the traffic engineers are, it's constantly changing. It's never static, and as soon as they optimize something, it changes again, because now people are like, well, it's quicker for me to go this way, right? So without that detection, like how often can a traffic engineer actually get to retime a corridor? So that adds so much benefit to the traveling public in general. It's just being able to see what's going on and adapt to it in real time.
Hey everybody, welcome to another Pulse podcast from Wavetronics, where we talk about transportation, traffic. I'm Todd Hansen.
And I'm Caden Baird.
And we've got a couple of very special guests that we want to introduce you to now. Derek Lowe joined Avenue Consultants in 2023 with over 20 years of software development experience, including more than a decade at the Utah Department of Transportation, where he helped develop key traffic analysis tools like ATSPM. He now leads a team focused on advancing UDOT's ATSPM system and creating innovative software for transportation agencies.
And we'd also like to welcome to the show Shawn Larson. Now, Shawn has been with Avenue Consultants since 2013, leading their traffic signal operations team and optimizing hundreds of intersections across multiple states. An expert in traffic signal optimization and operations, he has played a key role in developing automated traffic signal performance measures, including innovations like Green Time Utilization and the time-space diagram. Welcome to the show, guys.
Thanks for having us.
So if you wouldn't mind, each of you just telling us a little bit about your background and how you came into the traffic industry, specifically with Avenue now.
Yeah, sure. So I'll go first. I actually had no intention of working in the traffic industry, being a software developer. I'd worked a few different places and happened to get a job with the DABC, the Department of Alcoholic Beverage Control, and saw a position open up with UDOT. And I'd actually worked on a case study in college in software programming. I thought, that would be pretty cool just to see where this goes. And so I applied for it, and lo and behold, I got it. And so here I am, 12, 13 years later, still doing traffic stuff, and really had no intention of ever being in it. So,
wow. Shawn?
So I joined Avenue Consultants. Actually, it was my first job out of college. I had just graduated and applied and found an open position there. And at the time, actually, Avenue Consultants, there was only about 15 people. So it was pretty small. This is a few years ago. And so I joined, and I always was interested in traffic in school. There we took some classes in traffic engineering and traffic operations. And so that was kind of where I wanted to go. And Avenue at the time was a purely traffic firm. And we've grown and added multiple disciplines and different things. But at the time, it fit really well. And so I started there. And particularly in the traffic signal operations is one of the contracts. And when you have a firm of about 15 people, you work on a little bit of everything. And so I started working on that. I found a big passion for that. And I just like, especially in that area, just being able to make a difference in people's life, even though they may not realize it, but their commute home hopefully gets a little better after we do our work on a signal corridor, or it gets a little bit safer, or we are able to make a positive impact and do it quickly as well. A lot of other projects we work on, maybe it takes decades for them to get built, but this is a way we can make an impact pretty quickly and pretty significantly.
Now, Derek, you've been with Avenue a little bit more briefly, but you have had a lot of experience within the industry itself. You spent 10 plus years with UDOT, correct?
Mm-hmm.
What was that experience like, and how did you make that transition from UDOT over to Avenue Consultants?
Yeah, it was great. It was like it sounds kind of nerdy, but it was like my dream job. I loved doing it. It's fascinating to me how all this stuff works. Working with traffic engineers, they're just generally really brilliant people, and they have all these ideas that then I get to bring to life, right? I get to build an application that actually does what they're trying to do, and I can make it happen in an instant, whereas before they would have had to manually do some of this stuff. So for me, it was great, and I did that for a long time. there was a specific skill set that I was after, that I felt like I needed to leave the state to be able to get. I wanted some cloud experience, and an opportunity popped up with another company, and so I ended up leaving the state. But as soon as I left, they actually reached out to someone at Avenue and said, "Hey, we really need Derek's help." I had built the ATSPM application, and they said, "We really need help with this. Would you guys see if maybe you can hire him?" And they reached out to me, and I was like, "Well, I really need this experience for my career trajectory, but I'll moonlight with you guys and just help kind of keep things going for a little while." And so while I worked at this other company for a couple of years, I also did part-time work for Avenue. So technically, I guess I started in 2021, but I did that part-time for a couple of years, and then eventually they convinced me to come on full-time, and I realized that this is kind of my passion project anyways. This is where I wanted to be. So got to get the experience and still do my passion stuff. So
it really does sound kind of nerdy.
It 100% is.
Yeah.
100% is. Like I said, my wife always finds an excuse or an emergency in another room whenever I start talking details about what I do. But.
Well, because it's so cool. And explain what ATSPM is and why it's so important.
Sure. So it's automated traffic signal performance measures. Bit of a mouthful.
Yeah.
But it is a application that is system agnostic, because there's a lot of different equipment and systems out there in the traffic world. And its primary goal is to retrieve. For years, they were all the intersections were recording this data at the intersection level, and nothing was being done with it. It just basically went away. And so Mark Taylor at UDOT and Jamie Mackey, who's now with FHWA, and a lot of other big players had this idea of what they could do with this data, but they had to be able to get it from the intersection to somewhere where they could store it and then process it, because it's a lot of data. It's not a trivial amount of data. And so when I first started there, my boss came in at UDOT and said, "Hey, Mark's got a report he wants you to write. Just go meet with him. I got some other stuff ready to work on, so don't take too long." And 13 years later, I'm still working on that report. So, but it gathers all that information. It stores it in a central location. And then we have layers built on it that we can aggregate the data. We can display it in a way that makes sense to the traffic engineers so that they can time the corridors efficiently. And, Mark Taylor's saying was always, why model when you can measure? So instead of guessing at what's happening on the roads, you now know what the vehicles were doing because you can see it right in front of you. And you can make a change and see what effects that has on the system as a whole.
Where does all this data come from?
So all the data lives at the intersection itself. The controllers, the signal controllers, store all this information. So, every time a vehicle drives through, every time the light changes from red to green or green to red or whatever, that's all logged at each intersection. And then we wrote the application to go out and retrieve that data, pull it into a central database, and so that we can process it for each for the traffic engineers to review. Our first iteration of this, we didn't really realize how big the data was. In fact, our database grew to something like 60 or 70 terabytes of data before we were like, okay, we might need to get rid of some of this older data. So our new application, we've since added some new features to it, and we now compress the data, which makes it a lot easier to store all this information. But yeah, it's a big lift. There's UDOT has 2,300 signals, and so we have to go out to each of those every few minutes and pull in their data so that the traffic engineers can see what's going on out there.
Have you guys always utilized your own ATSPM type software? Did you ever contract that out to a third party, or how has that worked for you guys at Avenue?
Yeah, actually, in the beginning days, UDOT wanted one of their vendors to build it, a few of them, and they went to him and asked him, said, "Hey, we've got this data. Would you build something for it?" And basically was told, no, we don't see any future in it. And so their goal was, okay, well, let's make something that everybody can use. Again, system agnostic, and it'll be produced by UDOT, but it's an open source product. So any agency can have it for free. Our specialty is helping them set it up, customize it to whatever their particular needs might be, but it's available through, and UDOT's getting back the enhancements that other people are using. Kind of the whole idea behind the open source ecosystem, right, is they put some in, somebody else makes an improvement, and UDOT gets that for free. So that's the model that it's all built off of.
So let's talk traffic signal optimization. Shawn, in a perfect world, what is the ideal traffic signal optimization that everybody wants as they're driving, right?
Well, in an ideal world, obviously, no one would ever have to stop at a traffic signal. Everyone would arrive, the light would be green, and just could be able to go through. But we know that's not really possible, right? There's enough competing movements, there's enough different things going on at the traffic signal that you can't have everyone not have to stop. But ideally, on most of our major corridors, we do try to make it so you don't have to stop along the main corridor. So you're driving along Redwood Road, State Street, one of these big corridors that has a lot of traffic. We want to stop people as least amount as possible. Now, it may not seem like it for the average driver. I know sometimes, you arrive and you're stopping a lot of signals and you're like, well, why am I doing that? But in general, we're trying to make it as best we can. But there's a lot of variables we have to consider, with pedestrians also crossing, the left turns also have to have a time to go. There's also the distance between signals. Sometimes you have signals that are really tightly spaced. And so, maybe we can't get perfect progression or vehicles arriving on green both directions through those two signals and you have to stop at one of them. There's a lot of other things to consider, especially when it comes to safety. We want to make sure the first priority is always to make it safe. And then we want to try to get everyone home as quickly and efficiently as possible. But that's kind of the second part of it, right? That safety is the most critical thing.
Maybe could you go into a little bit more detail? How have you guys made the jump through your ATSPM software and maybe a lot of those different metrics from focusing on maybe a single intersection to optimize and then being able to do that for a whole corridor of intersections?
Yeah. And so one of the things that, just kind of step back a little bit, before ATSPMs, the traffic signal operations engineer, often what they do is they go out and they'd look at a corridor maybe for a day and they go collect traffic volume. So the number of vehicles making a left turn, number of vehicles going through, and all this information from one particular day. And then they go back and they'd actually build a model of it so basically a software program that says, okay, here's my intersection, here's my volumes and stuff, and then allow me to kind of build and say, okay, this is what I think is the best operation that we were going to get out of it. And then go put it in and see if that works and maybe do some testing and stuff. Well, like what Derek was saying earlier, and what Mark Taylor is one of his best sayings, is why model what you can measure. Now with ATSPMs, we're actually able to measure not just at one day, but multiple days. Look at the traffic volumes, look at how long was my left turn phase, the amount of green time I gave to this movement that served all the traffic volume. How many times there's a left turn that doesn't serve all the traffic volume. People are waiting multiple cycles and no one likes to do that. And so there's a lot of data there that we're able to get. And especially looking at it as well from a corridor level now, because each intersection is important, but also people don't drive through just one intersection. You drive through a bunch of intersections and you're trying to get where you're going faster. And so we have to look at how they arrive between different intersections. And in particular, one of the things we spend a lot of time on is coordinating along a corridor. By doing that, what we're doing is actually selecting the movements along the corridor and setting the offset. So basically, okay, when does the movement at this corridor start compared to when it started this one? So vehicles, when they leave one intersection, hopefully will arrive and it'll turn green for them and they get to go through that next one without having to stop that long. Well, some of the data from ATSPMs, so the Purdue coordination diagram, tells us how many vehicles arrived on green. Tells us, if we did a good job making that, setting the offset, so more vehicles were arriving, during that green phase and don't have to stop and wait. And also one of the new features in ATSPMs, which is one of my favorites, is the time space diagram tool. So time space diagram basically is a diagram that lays out time and space and shows you how vehicles are going to arrive when you leave one intersection to the next intersection. And as a traffic engineer, it's one of the best ways to look at how a corridor is going to operate. And this time space diagram in ATSPM is based off of historical data of, we know when the light turned green, we know when it turned green at the next intersection, and we're able to kind of look and say, did what we put in work well or not? It gives us that feedback that we need to be able to say, okay, we continue to make some improvements because what we've initially put in worked okay, but we can do better. And so there's just a lot of information there. And the more information we get, the better we can do at our jobs.
If only every intersection, every roadway were exactly the same, be a whole lot easier, right? But
yeah,
it's so unique all across this country.
And the other thing is the space between signals. because there's certain speed that you might drive that you're going to arrive, maybe a minute later at the next signal. Well, then the signal after that, maybe you're going to arrive in 20 seconds. And so the space between them changes how you arrive at the intersections, and the speed limit changes that. And there's so many variables you have to look at.
What do you think is the biggest impact of what you two do for the average driver that has no idea? They're completely unaware of everything that goes into traffic signal optimization and safety of roadways.
Yeah, well, I think one of the things I always thought about is it's actually probably a good thing when people in our line of work don't notice it, right? You may not notice that extra minute that you're saving driving home or driving to work or different things like that. But that's, in a way, it's a good thing. When we're doing a great job, likely you're not going to notice it as much, because you always remember the worst times, right? When, there was an accident here and I had to wait 4 minutes to get through this signal, or something went wrong. That's generally when people remember. So you kind of want people not to remember your work that you're doing, and maybe not even notice as much that you're getting there a little bit quicker and a little bit easier every day.
Kind of following up with signal timing. They say that signal timing is usually only as good as your detection. Can you elaborate a little bit more on maybe that side of things, as far as your detection goes, and how you're integrating that within your ATSPM software and the data that you guys are retrieving?
Yeah, and that's absolutely true. Detection is super critical for an intersection, because I don't know if you've ever had that experience where you arrived at a traffic signal and you're waiting there and there's no other vehicles going through, but the light's not green for you. Well, I think a lot of people have, especially middle of the night or something like that. And it can be frustrating. You want that light to turn green, and to do that, we need to have good detection. And actually, there was an experience that we had a while back. There was an intersection that it was along a major corridor, and the detection over the weekend had a problem. And so it was stopped detecting vehicles and was actually extending on the side street, or the minor phases. So the kind of like our main road and then our minor phases, was extending those out to the full time. And during the PM peak hours, we had a lot of volume coming down this road during the PM, so about 4 or 5 o'clock. And typically at this intersection, the detection would allow those other phases to end early and give that time back to this westbound movement that needed a lot of green time. Well, over the weekend, it had stopped doing that. And we actually ended up seeing was that intersection then started queuing up to the next intersection, because it wasn't getting all this time that it was supposed to get because the detection wasn't working right. Once that detection was fixed, it went back to being normal, and now we didn't have this queue that was backing up and getting people calling in about, because it was unusual, and you don't want to wait 4 or 5 times to get through a green light. And so the detection was super critical on that part. And then unfortunately, that one was an example where the detection didn't work right. But most of the time when it's working right, it allows for a better operation of the traffic signal to really put that green time where it's needed, because we don't want people to sit and wait for a phase that's got no vehicles actually going through it.
Derek, do you have some thoughts on this?
I was just thinking it's a lot like adding brains to an intersection, right? Like it makes it so much more intelligent and adaptable to what's actually happening, because as good as the traffic engineers are, it's constantly changing. It's never static, and as soon as they optimize something, it changes again, because now people are like, well, it's quicker for me to go this way, right? So without that detection, like how often can a traffic engineer actually get to retime a corridor? So that adds so much benefit to the traveling public in general. It's just being able to see what's going on and adapt to it in real time.
Now you guys both seem super passionate about the ATSPM side of things. And I'll ask this to both of you. I know you just had related a previous experience, Shawn, but is there a time where you guys have really seen been like, yes, like this is how this is making a difference, this is how it's making an impact? Is there a specific situation, a specific intersection, a story that you guys might have that kind of proves this concept of what you guys preach about all the time?
Yeah, I think in general, part of what the great thing about the detection and also the ATSPM and how they kind of work together is that we are seeing what the intersection is seeing. The intersection, it's a computer. It basically gets all these inputs and then provides this output of green light here, red light here, green light here. And so you'll be able to see, and there's often where there's, someone calling in and saying, hey, this light's not working well, or this light's doing something like that. And with that ATSPM data and understanding the detection out there and seeing, well, I've detected a vehicle here, have this, you're able to kind of see, well, what went wrong at the signal? What do we need to fix so that it actually works well? In particular, there was another instance where there was a school that just got built at an intersection. And so we saw a huge increase in vehicles making a left turn onto this road that previously had a pretty low impact on the, low volume for drivers. And so we were able to look at the ATSPM data and say, oh, yeah, we need to actually add some more green time here because we are seeing that. Typically before the ATSPMs, you'd probably go out there, and with a school, you can kind of say, okay, this is probably the time when you go out there. But often when you hear these issues, you may not go out there at the same time and be like, well, it seems to be working right. You can't go back and look at the data without this, ATSPM. And so it just allows us to really see what the intersection is seeing and seeing it at the time that the issue happened as well.
Yeah, I can think of a couple scenarios come to my mind and from my perspective as a software engineer, I don't get to see some of the cool things that they do, but I get to talk to the traffic engineers. And sometimes it's like a kid in a candy store. Once you put out a new product and they're like, this is amazing. The time-space diagram that we just barely built with UDOT, we've had a couple engineers like purposely calling just to thank the main guy over at UDOT and be like, this is an amazing tool. Like I had no idea that this was even possible. So from my perspective, like the traffic engineers themselves, the ability, they talk all the time about how they used to have to send interns out to do counts and things like that. It just has changed their whole ability to, they were always understaffed for how many signals there were, right? But now they have technology that can help them do more with less. As well as I think it's helped understand some of the complexities of traffic in general. We have a tool called the Link Pivot tool, the Purdue Link Pivot. And it's an interesting one, but it basically takes every vehicle as it arrives at the intersection and moves it forward all the way through the cycle, 1 second at a time, and all the way back to see if these cars had arrived at this point, they would have gotten more cars through. And then it kind of gives an analysis. And when we first made it, they were really excited about it. And so they went and changed a whole corridor to match this new report we'd built. And it did not work out well. It went south quickly. And so they went and quickly changed it all back and they looked at it and they started to understand some of the complexities that exist around these, that you can't just change a complete corridor in major ways all the time because it totally changes the nature of that corridor. So what they found is they can go take the worst one and they can tweak it a little bit and make that one better and then watch it and see how the patterns and the behaviors change. So just a complete and total different understanding, I think, of what traffic actually does is it brings a lot of visibility to that world.
And were you in on the ground floor of ATSPM in the early days with UDOT, Purdue, Indiana?
Yeah. Darcy Bullock was the brainchild of the data format, and that happened a few years before I arrived. But when I started at UDOT, like I said, Mark Taylor, Jamie Mackey, Shane Johnson were there, and we started it from scratch. And so it was Mark and Jamie who were the traffic engineers. It was their brainchild, right, to do the software. And Shane and I built it from the beginning.
So what would the state of our roadways with so much crazy growth over that time be without ATSPM?
I think you can still go see it in some places because they don't have ATSPM and they're stuck guessing and modeling. It would be much worse, I think. Just like I said, because with growth, you can't get a traffic engineer out there all the time to change it. But now they can get there much quicker without going out to the site. They can just look at it. There's also a piece of this that, going back to detection, we have a thing on the ATSPMs called the Watchdog, and it goes through and it just analyzes the data every night and it looks for problems. So before, the only way that traffic engineers really knew there was a problem is if somebody called and complained, right? Like, I waited this light for 5 minutes before it turned. Well, now it goes through and it says, hey, you've got a bad detector out in the field. You should really go look at this. Or you've got a stuck PED that's constantly messing with the timing of this intersection and it's backing up. And so now they can go through and send technicians out before the public even notices what's going on. So in my opinion, I think it would be much worse without it.
It seems like you guys kind of serve as an example nationwide or even beyond that as far as ATSPMs go and how agencies might run their traffic signal optimization. How has your guys' work that you've done on this impacted other agencies around the country and maybe beyond that?
So I think part of it is Utah has kind of been leading the effort a little bit with ATSPMs. There are a lot of other states that use ATSPMs or have some sort of ATSPM data that they look at and have contributed even to the open source, because like they were saying, it is an open source product, and so other states have added different parts to that as well. But I think Utah is unique in that they kind of saw that vision early and they wanted to connect all their traffic signals, because that's one of the critical components of it as well. You have to be able to connect to that traffic signal to be able to pull the data from it. And UDOT has connected, I think it was 90, I can't remember the exact percentage. Most of their traffic signals are connected to kind of their network and are able to go in and pull that data from it so that they can pull that back and put it into all these different reports. And that's something that, they've done really well at. And they saw kind of this vision of doing that and then also building the system with ATSPMs. And so they are a little bit ahead, I think, a lot of different places. But I think that they've also made open source so that people have that available, or they try to spur that on and push that frontier and try to make it so that they really want, and we really want everyone to have as much data, as much information, and want to make sure that we push that industry forward as it makes an impact in people's lives, whether they realize it or not. That extra minute, couple extra 5 minutes, it does make a difference.
Yeah, I think nationwide people have just caught on to what you can. We work with a lot of different agencies, and there's just that desire there when they see what UDOT has been able to do, not just UDOT, but GDOT, Florida. I mean, I think at last count, it was over 50 nationwide that are using the open source software. And so people understand what the potential is there. As far as what it's changed for them, I imagine it's pretty similar to what it's changed for UDOT, is that we can now do more with less.
Being a little bit ahead, like you were saying. I mean, that's important. That's so cool to be a little bit ahead. How important at Avenue is innovation?
I think it's critical. We always are looking for new ways to do the things that we want to do, and make sure that we kind of think them through, and we don't want to. We want to make sure we innovate, but innovate smartly and intelligently. But I always think that just because something is we're doing it the way we've always done it is not necessarily a good reason to do it that way. We want to make sure that we think through the process and think through why we're doing things, and make sure that we do it intelligently. And like I said, step by step, kind of, line by line. But we want to make sure that we continue to innovate and continue to think about new ways to make things more efficient, make things better, do things in different ways that we haven't done before.
One of the things that you guys do that helps innovate is through something called Speed Listener. Could you guys elaborate a little bit on what that is and the impact it's making?
Yeah, so the Speed Listener is a really cool tool that we work with the advanced sensor from Wavetronics. And it has the feature where it can, I kind of described earlier how we go to the intersections and we pull the data. But the Speed Listener actually has the ability to just wait and see what data is passed to it. So UDOT has deployed these in, I can't remember how many locations, probably over 1,000 different locations, where it's sending back the speed data about 300 to 400 feet back from the intersection. So as the signals are approaching, or as the vehicles are approaching the signal. And with that, we collect all that data again into the system as it comes in, and we can then provide that data. What are the average speeds at all these locations? What is the general public doing? And we're actually in the process of expanding that, because a lot of these new sensors will provide more than just speed, right? They can even start including classification, size, a whole bunch of other information that wasn't there previous. So now all that data is pushed up to us, and we can now show again that to the traffic engineers so they can start making decisions about speed limits and whatever, all the other things that the traffic engineers look at the speed for. So yeah, it's a really cool tool. We're in the process with our new version of updating that to be able to handle more, because we've just seen how critical and how important that is to the system to understand the flows of traffic out there, right? If you're timing a signal for people to take a minute from one intersection to the next, but everybody's going 15 miles an hour over, it doesn't matter what you do there. They're all going to end up on red, right? So just having that understanding again of what's going on at the intersections and how the vehicles approach it is really critical.
Shawn, did you have some thoughts on that? I just saw you nodding in agreement.
Yeah, I think understanding that speed, like Derek was saying, helps us to be able to set the offsets or set when the green time should start, a little bit, do a better job of setting that. And also, I think it just comes back to making sure that we also want people to drive safe speeds on the road. So understand what is the speed that people are going out there. Is there something we need to do to maybe help adjust the road to make sure it matches that speed that people are driving, or be able to make sure that people are being safe. And also, some of the critical parameters like the yellow and the red time at traffic signals. When you're coming on traffic signal, you want to make sure that you have those set right so that when it does change from one phase to the next phase, it does so safely. So there's a lot of information, a lot of things that we want to make sure that we're setting correctly, and want to know the speed people are driving on the roads to do that.
Does it generally seem like more people are speeding when in these scenarios, or what's the kind of that data looking like? Obviously, it's helping optimize intersections in between corridors, and you hit definitely on the safety issue with that. So I'm just curious, is it a lot of high-speed vehicles, high-priority, bigger vehicles that are maybe causing issues, or what's kind of the data looking like on that end?
I think it kind of depends on the individual corridor as well. When you have a really straight road with a pretty wide, it gets really easy to go a little bit faster because you're kind of comfortable, and but on a road that maybe has a lot of curves, maybe really tight lanes, people tend to drive a little bit slower. So it really depends on the corridor by corridor a little bit, and the design of that and the design speed. But I think in general, we definitely want people to follow the speed limit because it's a little bit safer when everyone goes the same speed.
We're actually adding a module to ATSPM, and it's called the Speed Management Tool. And it not only looks at the data from the Wavetronics sensors, but it pulls in some of the probe data and some of the other data sources, the PEMS side fire stations that are out there. And it pulls all that in and lets us do some analysis. And overall, I would say the data looks like everybody speeds. So everybody goes 5 to 10 miles an hour at the least. But I would say that it really helps us starting to pinpoint where we were looking at the data a while ago, and you could see at like 5 a.m. on a certain freeway that somebody was driving over 100 miles an hour, like at almost the exact same time every morning. So somebody was either going to work or getting off work, and nobody was on the road, and so they were just flying. So, I mean, stuff like that, it's really interesting to see just some of the patterns you can pull out of that speed data.
Everybody's speeding except for everybody in front of me on the way to work every day. I don't know how that works. We've talked about nerdy dream jobs and stuff. What to both of you is most fulfilling about what you do?
I think it kind of goes back to what I said originally, just the impact that we are able to make from a traffic operations standpoint. A lot of times when we work on other projects, maybe it's, building a new interchange, maybe it's updating an interchange to be able to meet traffic demands. Those are kind of long-term things. We may do our part and then we don't see it actually built for 10, 15 years even. And so, but when we're going out there and we're making a change to the traffic signal operations, we might make that change, in a week and be able to see that improvement that we made pretty quickly there. And so it's just to be able to make that change soon, so we can help people and make the best use of the infrastructure that we currently have. Because we already have the roads out there, we already have the traffic signals. We want those traffic signals to work the best they can so that we use that to what we currently have the best.
For me, I would say there's probably twofold. As one, technology is so cool. Like there's so many cool things out there. It's just like, for me, it's like, which toy do I get to play with today? Right? There's awesome things out there. But also, I kind of going back to what I said before, is just when I get to talk to an engineer and they're like, this has changed my job completely. Like I can do so much more now. I can help more, have more impact on the traveling public. So for me, that's what makes it the dream job.
Maybe, and you guys might be good to do this for our audience, could you put in perspective maybe a little bit, even the last maybe 10, 20 years where we've been at as far as traffic signal optimization, detection, where we are currently and what you guys are using, and maybe from 10, 20 years from now where we might be headed, and kind of see maybe the jumps we've made and the jumps we definitely could be making as we move forward into the future.
Yeah, I think definitely the technology has improved for our detection. We're able to do a lot more things like count individual vehicles in an intersection or understand like the speeds that people are going, where previously, before some of the newer technology that came about with, We'vetronics in different places, being able to do a little bit more at the intersection, have more detector zones, I guess, put out, gather more data. And so doing that, we're able to get a lot more information that previously we weren't have. And I think as we continue into the future, it's going to get even better, particularly being able to identify maybe pedestrians or cyclists or different things along those lines, to be able to understand how pedestrians and other users of the system are going about using that, and how long are they waiting at the crosswalk for? What can we do to make that safer? Are they still in the crosswalk after it's coming down because we don't have long enough time for them to accurately cross when they're maybe a little bit slower, maybe they need a little more time. So there's definitely things out there in the future that will be able to allow us to make it safer and better and operate everything a little bit better. And I think it's just the more information we get to, the better decisions we can make.
Yeah, I would say just technology in general. Like you think 20 years ago, and what they had were loops, right, in the road, and that was pretty much it. That was your detector, and if that went bad, you had to dig up the road to do it, to fix it, and that's if you knew it was bad, right? Where we are today, which we have detection. I don't think people realize quite how many detection zones are at an intersection. I think they have up to 64 that they can do, 64 detection points in a single intersection. And that's what we have today. Now, what's coming tomorrow is incredible. We work a lot with UDOT on the connected vehicles platform. I don't know if you guys have heard anything about that. We're building a few tools for them to set that up. But when the vehicles themselves are communicating real time with the intersections, I mean, where does that lead you? I mean, it's unlimited possibilities. For self-driving, but also for safety. Well, I mean, they're going to do a lot better at all of this than we can possibly do. So it's pretty exciting what's out there.
It seems like things potentially are kind of headed in the direction of, shifting is from infrastructure to vehicle, and then switching that from vehicle to infrastructure.
100%. Yeah. I mean, we're already kind of doing that. I mean, everybody who's driving along, if you're using your maps, that's being reported, what you're doing, and that's being fed back through, and that's a lot of the probe data that comes back through us. So it's just going to get more and more to where the vehicle really is saying, hey, I'm coming up on this intersection. How long am I going to have to wait? Right. That'll be cool.
I've already had the conversation with my kids that when I'm not safe to be driving anymore, take away my keys and remind me we had that conversation. But I hope by then the car's just going to drive me there and it won't matter. Is that going to happen in my lifetime? We've been talking about autonomous vehicles for so long, but it's not a reality yet.
I don't know. Have you driven in a Tesla lately? Well, I got a guy who has a Tesla that works for me, and he took me the other day. He just put in the directions he went, and it drove us, including parking, all the way. So I'm with you there, though. I hope that I'd like to take a nap in the car as opposed to having to do it all myself, right?
Exactly.
Go to sleep and wake up in St. George or something.
So with all of this technology advancing at a pretty fast rate, what technology that's currently out there do you guys see here to stay and adapt to this adjustment as the technology advances, and what might become outdated?
Connected vehicles obviously has been a big one. That's just in its early days. Still, even though it's been 10 years, I think, since UDOT started really hammering it, but a lot of the hurdles are kind of starting to fall away. UDOT has a really big deployment coming up, so that vehicle to infrastructure communication is, I think, going to be here for the long term. We see, I mentioned a little bit earlier, detection that gives you more than just the speed and there's a car here, right? Now we say, okay, there was a truck here and it had this many wheels on it, and there was also a pedestrian who started entering the roadway at this time, and there was a near miss and there was an accident, and all this technology can tell us this now. So I feel like that's probably the future of it, and it's all going to help with the timing, but it's also going to increase safety tenfold, right? If you know there's a problem there, then you can do something to mitigate it. We just don't always know now when there's a particular issue there.
You work a lot with UDOT, which makes sense because it's local to you. Your headquarters are here, and you used to work there. And they're really, I mean, they're a gold standard of DOTs around the country. But I'm curious, what other states you work in with Avenue?
We've been doing a lot of work in Texas recently, Frisco and Bryan, Texas. We've been working with. We've been starting to work with Portland, Vermont, Georgia, all of those places. We've been working with, trying to get them up on the more recent version of ATSPM and incorporating some of their ideas. Really, I mentioned I'm always impressed with the traffic engineers and their ideas. Just when you think you're kind of the expert in an area, you start talking to them and they're like, why did you do this? Well, this is a way better way to do it. And you're like, you're right. We should definitely do that. Let's do that. Right. And they're all over the country and they are excited about it. And they're working to add a lot of new improvements to ATSPM.
What does growth look like for Avenue?
Gosh, we have so many different areas of growth. I think for my division, which is the kind of the software technology division, it really is nationwide, in bringing more of those clients on and helping them capture the vision to do that. It might be slightly different for I'm kind of a little different area of what Avenue does. So what do you think, Shawn?
Yeah, no, I think it's absolutely true. I mean, we love supporting our clients and providing good value, and we believe in, especially in our traffic signal operations part of it, we believe in ATSPMs that it does allow us to do a little bit more. And so we encourage people to get on board with that, even if it's something that, they just could use the open source or maybe even a different product. But we want to encourage people to do the best we can with what we have. And we want to support our clients in the best way we can and help them to make good decisions about the future and about the operations out there. So
do you guys feel like you're pretty ahead of the curve as far as things go at Avenue Consultants with the technology and things that you guys are coming up with as you guys look, towards the future?
I think one of the things that sets us apart is just the experience with ATSPM data. Because we were located here in Utah, we've been using ATSPM data for over 10 years. And so it allows us to kind of have a little bit more insights and have seen a lot of the data and have had an influence on some of the newer measures, the time space diagram, the Green Time Utilization measure, and all these different things, and to have a little bit more background knowledge of some of those things. And it gives us a little bit of insights into what we can use it for, what the value we can get out of it, how we can use it to modify and do what the typical process that people go through to retime their signals or do different things, or even create reports to say, okay, this is how well your signal's working. Or there's a lot of things that, because of our experience working on it, I think it kind of helps us to give that value back to our clients.
Yeah, and I think too, we get to work with innovative people. At least my part does. It's not, I can't claim to have been the brainchild behind most of these things, but I get to make their dreams come forward. So I think we're innovative in that way, and just finding people's ideas that are innovative.
Well, we've had you in the hot seats for a while now. Is there something that we haven't asked that you're just dying to tell us about Avenue or traffic in general?
I think we covered it pretty well. I mean, obviously ATSPM is our passion. I think that we have done a lot, and I think there's a lot more to do. And we're always looking to find those people who want to do it and partner with them so that we can make that happen.
How can people contact or get a hold of you guys at Avenue?
So I think there's email us, or we can.
Yeah. So we actually just set up ATSPM at avenueconsultants.com. So that's an easy one to remember, but also a call or a phone call, email at dlo@avenueconsultants.com.
Okay. Perfect. Thanks for joining us today, guys.
Thanks for having us.
Thank you.
It was
Interesting.
awesome.
Derek Lowe and Shawn Larson from Avenue Consultants. We appreciate it. And we appreciate you being here on the Pulse podcast from Wavetronics. See you next time.